Hey guys, I know you miss Miss Williams, but guess what? I'm not too far away because I am right here with you digitally. So let's hop right into our lesson for today. Before you leave, you should be able to say I can add, subtract, and multiply polynomials. So here I have an example. 3x to the fourth minus 2x cubed plus 5x squared plus 7x squared plus 9x cubed minus 2x. All right. So remember, with adding polynomials, the only thing there is to do is combine like terms. So do I have another x to the fourth term? I sure don't. So I'm just going to bring that down. Do I have another x to the third or x cubed term? Yes, I do. And as you can see, I kind of did some pre-writing before we began. I went ahead and circled my like terms. So negative 2x cubed plus 9x cubed, that's just like subtracting. So I have positive 7x cubed. Do I have another x squared term? Yes, I do. As you can see indicated in my rectangles, I have 5x squared plus 7x squared, and that would give me 12x squared. Do I have another x to the first? No, I do not. So I will just bring that on down. So as you can see, what's most important is that I combine like terms and then I put it in standard form. Standard form requires me to write down my highest degree or my highest exponent first. Okay, so I have 3x to the fourth plus 7x cubed plus 12x squared minus 2x. As you can see, it's in descending order, 4, 3, 2, and 1. Okay, and we have simplified this as much as we could. All right, so take a minute to write that down if you don't have it already. Next up is our subtraction, our difference of polynomials. Difference meaning subtraction. We just finished up addition, meaning sum. So now let's do the difference of polynomials. So here we go. I have 11x squared plus 6x minus 1 minus 2x squared minus 7x plus 5. Here's the uber important part, all right? You see this minus sign right here? Okay, I want you to think of that like a negative 1 because you have to distribute this negative 1 inside of the second set of parentheses, okay? Every term in this polynomial should change, okay? So I need to distribute this negative 1 inside of the parentheses. So here's what I'm going to do. I'm going to take my first set and I'm just going to bring it down, my first polynomial. And then I'm going to distribute this negative 1. Negative 1 times 2x squared is negative 2x squared. Negative 1 times negative 7x is positive 7x. Remember, a negative times a negative is positive. Negative 1 times positive 5 is negative 5. Now, ladies and gentlemen, we can combine like terms. Do I have another x squared term? I sure do. So I'm just going to circle it to make it easy to identify. Do I have another x to the first term? I sure do. And do I have another constant? I sure do. Constant Remember, that refers to a number that stands alone. It is a constant. It does not have a variable that can cause it to change. So I'm just going to, excuse me, do my best to make a triangle here. I apologize. Here we go. It's my -1, and here is my triangle here. Don't judge me. I know y'all laughing. Don't judge me. All right. So here we go. 11x squared minus 2x squared. We're just combining like terms. I'm going to do what the sign tells me to do. So 11 minus 2 is 9. 9x squared. 6x plus 7x is what? That's right, 13x. And this was a 1. Okay. -1 minus 5 is just like adding. Remember, you take the sign of the bigger number. -1 minus 5 is -6. There you have it. Again, in descending order, x squared, x to the first, and then my constant is always going to be at the end. Take a minute to write that down if you do not have it already. And the substitute teacher can, of course, pause it here if you need more time. All right. Next up, and definitely not last, but we are going to tackle some product. The product of polynomials. Product meaning what? Multiplication. That's right. So I have two binomials. Bi meaning two terms. So I'm just going to multiply and make sure I multiply everything inside of the parentheses. Okay? I have w times w, which gives me w squared. Remember, when I have like bases, when I'm multiplying like bases, I add the exponents. W times 2 would be positive 2w. 5 times w is positive 5w. And 5 times 2 is 10. All right. Once again, combine like terms. I don't have another squared or another constant, so I'm just going to bring these two on down. Lastly, here are the like terms, 2w plus 5w, which gives me positive 7w. Once again, in standard form, in descending order, 2, 1, constant. Okay. Let's move that out of the way for the glare. And last but not least, 3b times 2b, and then 3b times -3, -2 times 2b, and -2 times -3. Okay, I draw these little rainbows and smiley faces just to remind myself that I have to multiply each term in the parentheses. So let's deal with our first term. 3b times 2b is, that's right, 6b, not just 6b, but 6b squared. Here's why. Remember, when multiplying like bases, we add the exponents. Moving on, 3b times -3 is -9b. 3b, I'm sorry, we've already dealt with the first term. Now let's deal with the second term. -2 times 2b is -4b. -2 times -3 is +6. All right. Do I have another squared term? Nope. I'm just going to bring it down. Do I have another constant? Nope. Just going to bring her down here. Lastly, do I have another like term? Do I have another b to the first power? I sure do. Now, what do we do here? Negative 9 minus 4. Take the sign of the bigger number. That's just like adding. Negative 9b minus 4b is negative 13b. And ladies and gentlemen, there you have it. We did the sum of polynomials, the difference of polynomials, and the product of polynomials. After you have written these notes down, you will grab a laptop, log on to ixl.com. Be sure to put in the proper username and password, and your substitute teacher will give you further instructions from there. I hope you guys have a great day, and I will see my A-Day people on tomorrow, Tuesday, and I'll see my B-Day people on Wednesday. Continue to be great. Thank you.